Okay guys, this is the video lecture for section 3.3, which is the last section in all of chapter 3. This one is not very hard. You're not going to be learning any new formulas. You're not going to be doing anything that you haven't done before. I'm just here to tell you that there's a really important trick that I need you to be aware of when you're calculating for AP quantities. And I want you to think all the way back to day one when we did that numbers game. Okay, remember there was a couple lessons that I wanted you to learn from that game, that ILA that we started with, and one of them was that if you remember, all the odd numbers were on the left side of the page and all the even numbers were on the right. And if I had given you that information, then you would have been much more successful, much more quick at solving it, and you would have known something that was really important. So what I need you to do is lean in right now and listen to what I'm going to tell you, because if you don't pay attention to this, you're going to make a lot of mistakes, both in the curriculum, in your workbook, on tests, and in industry. And this is something that you intuitively know. I just want you to pay attention for in your calculations, okay? So here's something that's important. So turn in your book to page 91, and we are going to talk about quantities that compensate for waste, okay? So what I want you to think about is that sometimes, and look at these pictures here, okay? Sometimes when a recipe writer writes a recipe, they will write, because think about it, let me back up. When you read a recipe, okay, usually it'll say something like you need 4 cups of medium diced carrots. Okay, maybe you're making chicken soup for a banquet or something like that. So let's look at this. If you're saying 4 cups, then you're telling me that this is your EP quantity, right? Because this is as purchased. 4 cups of medium diced carrots mean that you would have taken a certain amount of carrots, and what would you have to do to get them medium diced? You would have to cut off that stemmy edge in the bottom. You'd have to peel them. Medium diced, I think our last section, 3.2, there was a problem that told us that the yield percent was 81.3 yield percent, right? So the question would be, how many carrots do I need? How many do I need to order AP, right? So we would have done 4 cups divided by the yield percent, 81.3, and let me get that out and let's see what that would be. So that would be 4 divided by 0.813 means that we really would need 4.92 cups in order to end up with 4 cups. And then most of you would say, okay, but we never order 4 cups. So you'd say, how many pounds is that? And then you'd have to convert. You'd have to convert to find out the weight of a cup of carrots, and then convert that to pounds to know how many AP pounds to order, right? So this is an example of a recipe quantity, and recipe quantities are typically written as EP quantities, edible portion, right? Let's talk about another one. Okay. Let's say that in this one, so that was volume, we said 4 cups. Now let's say that you're going to make the same soup, but now, okay, so we said cups. Let's say that you need 32 ounces of medium diced carrots. Okay? So now that's an EP quantity. To make this soup, we need 32 ounces. But if we go to the store and we buy 32 ounces, which is 2 pounds, we're not going to end up with 32 ounces or 2 pounds, because we're going to throw away the peels and we're going to throw away the uneven pieces that don't give us a medium dice and the tops and the bottoms, right? So we need the AP quantity. So AP quantity again would be 32 ounces divided by that yield percent, which I think is 81.3. So 32 divided by 0.813 equals, well, now we're going to need to buy 39.3604 ounces, okay, AP. So in order to end up with enough carrots to have 32 ounces or 2 pounds that we need to make our soup. But let me tell you that a recipe writer sometimes will write a recipe in a way so that, and I'm going to say this slowly so that pay attention, so that the EP quantity is the same thing as the AP quantity, which means, let me see if I have a red marker. I do. Which means that if the recipe writer writes the EP quantity in a way that they're also saying just go buy that much, it's the same thing, you don't need a yield percent, right? So there are times that a recipe writer will write the recipe, the EP quantity, how much you need of an ingredient to make it, so that it's already expressed as an AP quantity. Let's talk about how that could be true in the case of this soup. Well, what if I was the recipe writer and I said to you, you need 6 each carrots, peeled and medium diced. Well, that's my EP quantity, 6 each carrots. I'm telling you that if you take 6 carrots, 6 eaches of the carrots, and you peel them and dice them, that's enough to make my recipe for chicken noodle soup. What I'm saying is I wrote my EP quantity, which is how recipes are typically written, but I wrote it already as an AP quantity, which means I don't need you to divide this by a yield percent to go find out how much you need to order, because guess what, right? What I'm saying to you is, hey, where's my red? 6 carrots is 6 carrots, right? If I say to you, you need 6 carrots to make this recipe, then I'm telling you, I'm fully aware that you're gonna peel them and dice them and you're gonna have less than what the weight would have been of the 6 carrots, but 6 carrots will make my recipe just right. So if the recipe is written by a quantity of each, then typically you don't need a yield percent. Okay, let's look at an example of this on page 91. So now they're looking at apples. Version A tells you that to make, let's assume we're going to make pie. To make this pie, you need 2.88 kilograms of peeled, cored, and sliced apples. That's an EP quantity, right? But in order to find out how much you need, you would have to divide by the yield percent. And so you would need to do that to get the AP quantity. Version B still tells me you need 1.5 gallons of peeled, cored, sliced apples. Well, if I only start with 1.5 gallons of apples and then I peel and core and slice them, I won't end up with 1.5 gallons of apples after I throw away all that waste. So I'd have to take 1.5 gallons of apples, divide by the yield percent of apples to get my AP quantity. But version C is just like my chicken noodle soup. Go get 20 apples. I know you're going to peel them, I know you're going to core them, and I know you're going to slice them. But I wrote this so that the EP quantity, 20 apples, is also the AP quantity, so don't use a yield percent. So stop and write yourself a note, and this is what the note is going to say. If the recipe quantity is written by eaches, you do not need to divide by the yield percent to tell you how much to order or AP quantity. One more time. If the recipe, which is an EP quantity, is written by an each, a quantity of count, then do not divide by the yield percent because it is already the AP quantity. If I say to you, I need 40 tomatoes to make tomato bisque, you're not going to take 40 and divide by the yield percent. Go to the farmer's market and buy 40. If I say I need 6 cloves of garlic, you don't have to divide by the yield percent to find out how many cloves AP to buy. I just told you, okay? The only thing that tells you when you don't need yield percent is how the recipe is written, the recipe quantity. Let me say this to you one more time. The only thing that determines if you don't need to divide by a yield percent to be an AP, to get an AP quantity, is if the EP quantity, or how a recipe is written by a quantity of each. Okay? Go on page 91 there and underline with me this sentence. Anytime a recipe quantity is measured by weight or volume, it is an EP quantity. So if the recipe quantity is measured by weight or volume, it's going to be an EP quantity, and you will need to divide by the yield percent in order to find out how much to order. But think about it. It's logical. You know this. If the recipe quantity is written by an each, just go by how many the recipe writer told you to buy. They get that you're going to throw away what's not needed, or they hope you're going to throw away what's not needed. But let me tell you what some students would do, and I don't want you to do this. Sometimes students will look at the AP quantity. Like, go ahead and turn to the next page. Okay? Now, turn to page 94. Okay? They'll look down here and they'll say pairs. Okay, pairs, AP quantity, 6 eaches, and then they'll go ahead and cross out the yield percent because they'll say, oh, that's eaches. That's not the rule. That's not the rule. The rule is if the recipe quantity, the EP quantity, is a quantity of eaches, then you cross out the yield because you don't need it. Okay? Let me tell you about, on page 92, your book gives one exception to this rule. I can't off the top of my head think of another, but you'll get it when you hear this. There is a weird eaches that is an exception to this rule, and we've talked about it in class a little bit. Your book says, you know, if a recipe says something like you need 120 melon balls, well, those are eaches, right? But you can't go to a grocery store or a farmer's market and order melon balls. You have to get a melon, you have to fabricate it, you have to get a melon ball, or a Parisian scoop is another word for it, another phrase, and you're gonna have a lot less, okay? So that's an entirely different thing. Melon balls is, I think, the only example that I can think of right now, because it's something that you'd have to fabricate. But if it says something like carrots or apples or garlic cloves or chicken breast, and it just says 20 eaches, then that's all you need to buy. So let's start working on some problems together. Okay, I want you to answer 1 and 2 together on page 93 and check your work in the back of the book. Let's look at number 3, which says, for each ingredient in the chart, use the given recipe quantities, equivalents, and yield percentages to determine the revised recipe quantity and the necessary AP quantity. For some ingredients, you do not need to use all of the information given. Okay, so let's look at the first one, bananas. I'm going to erase this. Okay, so bananas sliced, the recipe quantity says 4 eaches. Okay, so the recipe quantity, let me write this out here. It says ingredients, and then it says recipe quantity, then it says revised recipe quantity, then it says yield, and then it says AP quantity. Okay, let's start with bananas. That's our ingredient, right? So you follow along as I'm solving this. Let me make sure you can see this. You can't see the word bananas really clearly, but I'll make sure I write the numbers clearly, okay? And then it gives us the information that one each weighs 4 ounces. We'll decide if we need that. Like any time the book gives us book of yields information. So now it tells us that the recipe quantity, which is how the recipe is written, tells us that for this recipe we need 4 eaches. Then it wants us to revise to say how many pounds that is, because if you go over here, the reason it's asking us to revise to pounds is because we will purchase bananas by the pounds. And what this chapter and this section is getting us ready to do is what we're going to do in section 4, which is create orders. Okay, so we're going to take all these recipes that we've converted and added up, all the quantities we need, and then we're going to place orders with the purveyor to say, this is how many pounds of bananas I need. Okay, and it told us one more thing. It says that the yield on bananas is 66%. Now, what was the rule? The rule said, first of all, the formula we will be using is EP, right? Because this is the way the recipe is written, is by an EP quantity divided by yield percent will give us the AP quantity. But I just told you that if the recipe quantity is written by eaches, then you do not need a yield percent, okay? So right out of the chute, this says that the recipe quantity we need is 4 eaches. So how many bananas do you have to order to get to if you need 4 eaches, you would just need 4. So it's written by a quantity that tells you that I don't need that yield percent, so cross it out. Now here comes the slightly tricky part in this problem, is that we have to revise it to the unit that we buy it. So we need 4 bananas, but we buy them by the pound. So what that means is I can't call up and say, hi, US Foods, yes, this is Chef Decker here. I need 4 bananas. How many pounds is that? Hold on, I gotta convert. I gotta convert because I can't order bananas by the eaches. But I can because I know this. I know that 1 each weighs 4 ounces. So some of you could just multiply. If you can't, let me show you the bridge. So we're going to convert from eaches to pounds. We know that 1 each weighs a certain amount of ounces, so we have to connect these, as you remember. So our bridge is going to start with 4 eaches over 1. Then we're going to bring eaches down, ounces up. We're going to plug this information in. 1 each weighs 4 ounces, and then ounces to pounds. There are 16 ounces in 1 pound, so we get 16 over 16, which is the same as 1, which some of you just did automatically in your head by multiplying 4 times 4, but if you had to do this, who cares? Get there how you can. So we need 1 pound. Now, typically, this is the same thing, right? This is the recipe quantity, this is the recipe quantity. It's just expressing it with 2 different units. So typically, to get to AP, we'd have to take the EP quantity, which is how a recipe is written, the recipe quantity, divided by our yield percent. But since this recipe was written by eaches, we don't need to do anything with that. So we ignore that, which means that to make whatever this recipe calling for bananas is, 4 eaches revises to 1 pound. If 1 banana weighs 4 ounces, we don't need a yield percent, so that means we need to buy 1 pound. So I say, hi, I'm back. I need 1 pound of bananas. Okay, thank you. Moving on. Let's look at, let's see, which one do I want to do here? Let's do grapefruit because that looks tricky. Okay, so grapefruit. It's telling us a lot. 1 cup weighs 7.4 ounces and 1 each is 13 ounces. Okay, I'm going to get rid of the banana conversion down here. And let's start plugging in what they gave us. So the recipe says we need 5 cups of sectioned grapefruit. It wants us to convert to eaches, and remember, whatever we revise to here is because that's how we're gonna buy it here. So we wanna revise by eaches as the second step, so that then if we need to divide by the yield percent to get an AP quantity, we're ready to do so. And they tell us that grapefruit has a yield of 52%, okay? So now let's stop and ask the question that this section forced us to ask. Is this EP quantity or recipe quantity written by the eaches? No, right? And it said on page 91, anytime a recipe quantity is measured by weight or volume, then it is an EP quantity, which means we don't know the AP quantity because it's written by volume. We need 5 volume cups. Now we have to convert those 5 cups to eaches, okay? So we have to do a conversion from number of cups to eaches, and we have to decide how to use this. Well, I told you that in a conversion, if Book of Yields has it joined together, you can't break it up. So that means that cups has to connect to ounces in your steps of how to get to eaches. And then ounces does connect to eaches, so you can draw your line there. Now let's begin the conversion. 5 cups over 1, bring cups down, ounces up. How many ounces does 1 cup of grapefruit weigh? Well, 1 cup of grapefruit weighs 7.4 ounces. Ounces come down, eaches come up. 1 each weighs 13 ounces, okay? So when you do all that, you should end up with 2.846 eaches. 2.846 eaches. So let's write that here. 2.846 eaches. So all I did is revise. This still will 5 cups will be 2.846 eaches, but this is written by a quantity of volume, which means my EP quantity has to get divided by my yield percent in order to know how much to order, because I'm going to have waste. So now what we're going to do is we are going to take this quantity, the 2.846, and divide it by our yield percent of 0.52. And when we do that, we are going to end up with 5.472 eaches, which we will put right up there. So that's 2 examples on page 93 of your homework. One when you didn't need the yield percent, and one when you did need the yield percent. Okay? Now let's turn and let's look at a couple of the problems on page 94. Okay? So I'm going to get rid of this. Okay, now 94 says calculate the number of servings of the specified size you can get from a given AP quantity. Okay, so let's look at watermelon. So I'm going to draw us a new chart here. So now we have ingredient again. We have AP quantity now. We have yield next. We have serving size next. And then we have number of servings. So these are all the things that we have to solve, okay? So let's do 2 of these together. Okay, let me glance through and see which ones we might want to do. Okay, let's do watermelon first, okay? So watermelon, let's put the information they gave us there in case we need it. 1 cup of watermelon weighs 5.36 ounces. Okay, the AP quantity is 12 pounds, so that's how much we got in. The yield percent is 49%. The serving size is 1 cup, and they are asking us how many servings can we get out of this 12 pounds of watermelon. Okay, so the first thing we're going to have to do is find out what will we end up with. What will our EP quantity be? Because we know an AP quantity, and we know that the yield percent is 49%. But all we know is the size of our servings. We don't know how much edible we'll end up with, right? So let's start by using our formula. 12 pounds times our yield percent, which is 0.49, will give us 5.88 pounds of usable watermelon, okay? Now, we don't know anything about how many cups that will be though, right? So now we have to convert this 5.88. Let me adjust this. Let me see if I can get our lighting better here. Guys, hold still for 1 second. Helpful, right? Okay, so that's a little bit more helpful there. All right, let's get clear. Okay, all right, so we see the 12 times the yield percent gave us 5.88 usable pounds of watermelon. Worse. Okay. All right. So now we have to figure out, okay, that's great, but we want to know number of servings, and our serving size is 1 cup. So what we have to do is solve for how many cups is that? Well, no problem. We can do that. We just have to convert pounds to cups, starting with 5.88 pounds. Starting with 5.88 pounds, okay? So now we want to know 5.88 pounds usable, right? Because we got in a 12-pound watermelon. We know that we're only going to have 49% of it usable, which means we have 5.88. We don't know how many cups that is, but we can find out. Let's then use this. So we have to connect cups to ounces in our bridge. And then we know we can connect ounces to cups because we have that equivalency there. So let's go ahead and bridge this. Pounds comes down, ounces come up, 16 ounces in 1 pound, and then ounces comes down and cups goes up, and we know that 1 cup is equal to 5.36 ounces, okay? Now, when you do that math, you should end up with 17.55 cups, okay? And this one is kind of easy because your cup portion is 1 cup. So typically you divide by the number of cups in your portion, but any number divided by itself is that number. So the number of cups, number of servings that you can get out of 12 pounds of watermelon is 17.55, okay? Let's do one more together. Let's look at, let's see here. Let's look at grapefruit again, okay? So we'll stick to fruit. So grapefruit, and it tells us nothing about grapefruit, but it says that our AP quantity is 12 eaches, right? And it tells us that the yield percent is 52,
and it tells us that our serving size is 1/4 of an each. And now it wants to know how many servings will we be able to get. Okay, so let's go through and let's solve this together for grapefruit. So we're starting with 12 eaches, okay? So 12 eaches, and think about it this way. Okay, so let's say this is a grapefruit, right? So that's a grapefruit, and every time you get a grapefruit, you're gonna take it and you're gonna cut it in 4. 1, 2, 3, 4. So every grapefruit, you are going to get 4 portions out of it, aren't you? Right? You're going to get 4 portions. Well, you have 12 of them. Okay? You have 12 of them. So how many servings can you get? This is an example going this way, right? The recipe, the serving size, the way the recipe tells you is to make this whatever. You need 1/4 of an each. So this has no impact. We don't need this at all, because if we have 12 eaches here, and the serving is 1/4 of one, then 1, 2, 3, 4 servings times 12 of them mean that we will get 48 servings out of this. Okay? All right. So you work on the rest of these on page 93 and 94 for homework. We do have a Zoom session lined up. It's going to be an ILA to work on the section 3.3 worksheet together, which will be great to make sure that you really understand all this. So I'll see you in that Zoom session. If you need me in the meantime, join me in the chat or text me anytime. Good luck with your homework. See you soon. Bye.